Sri Guru Namaha. In last session, we have discussed the different types of operators. Today, in this session, we are going to discuss the precedence of operators, which means that in a particular given expression, you may be having many operators. Based on the precedence of operators only, we are going to evaluate the given expression. So here, the first precedence is here with the exponent, then the complementary, or it may be unary plus or minus operator, and then comes with multiplication, division, modulus, and floor divisions. Next is addition, subtraction, then comes with the right shift and left shift, bitwise and bitwise, or and exclusive or, right? So the next comes with the comparison, that is, we are relational operators. Next is equality checking operators. Then the assignment, augmented operators. Then identity operators, is not. Then membership operators, in, not, and. Then comes with your logical operators, not, or, and. So operator associativity, that is, in what order that you are going to evaluate a given expression, whether it is from left to right you are going to evaluate, or from right to left that you are going to evaluate. So Python allows multiple operators in a single expression. To evaluate the operator with higher precedence first. So in a given expression, whichever the operator which has the highest precedence, that operator should be evaluated first. If the expression contains two operators, right? So with that have the same precedence in the sense, it should be associativity helps in the order of operation. That is, if they have same precedence in the sense, which operator have to work, right? Whether I have to work from left to right or from right to left, which we call it as associativity. Associativity is the order in which the expression is to be evaluated. So how I'm going to execute my expression based on the order of precedence. All the operators have left to right associativity. So it has to evaluate from left to right, except the exponent operation. That is, this will work right to left associativity. So when you are working with the exponent operator, you have to evaluate from right to left, but other operators you can work from left to right, and you have to follow the precedence rule. We'll see some of the examples of how to evaluate a given expression. Now, I have an expression 7 . Now, I have an expression 7 into 8 slash 5 floor division 2. So, here we have different operators, multiplication operator, division operator, and floor division operator. All the operators comes with the same precedence. So, you have to evaluate the expression from left to right, associativity. Right? So 7 8s are 56 slash 5 more floor division 2. 56 divided by 5 gives 11.2 floor division 2. So 11.2 floor division 2, which is going to give the result as 5.0. This is how we are going to evaluate the given expression. If all the operators has the same precedence, you have to evaluate from left to right. Let us check whether we are getting the same result. 7 into 8 slash 5 and floor division 2. So we are getting the result as 5.0. Now we'll see with the next example. 3 into, that is exponent operator, into 3, again exponent operator, into 2, right? So how does your exponent operator, what is its associativity? It is from right to left. So first you have to work 3 into 2, that is 3 exponent 2. 3 power 2 is, which is nothing but 9. So 3 exponent of 9. So what is the equivalent of 3 power 9? Which is 19683. Let us check by execution. 3 exponent 3, again exponent of 2. So we are getting the result as 19683. Let us check with the next example. 6 into 3 plus 4 into 2, that is exponent of 2, flow division 5 minus 8. So how we are going to evaluate? Among all the operators, exponent has a highest precedence. So 6 into 3 plus 4 power 2 is 16, flow division 5 minus 8. So next is you have to work with the right, left to right associativity. So 6 into 3 is 18 plus 16 modulus 5. That is, here we have a plus and minus also, and we have multiplication and flow division. When compared with plus and minus, multiplication and flow division has the highest precedence. So first we have to evaluate these two, then we have to proceed with plus and minus, that is addition and subtraction. So you have to evaluate 16 flow division by 5, which gives the result as 3 minus 8. So 18 plus 3 is 21 minus 8. So your result is 13. Now we'll evaluate the expression. 6 into 3 plus 4 exponent 2 modulus, that is flow division by 5 minus 8. So your result is 30. Next example is 10 greater than 5 and 7 greater than 12 or not 80 greater than 3. Right? Here we have relational operators and logical operators. Among the relational operators and logical operators, relational operators comes as a first precedence. So 10 greater than 5, that is true, and 7 greater than 12, that is false, or not of 18 greater than 3, true. Right? So we have evaluated the relational operators. Now we are going to evaluate the logical operators. In logical operators also, we have a precedence of operators. The first precedence is for not, then goes with, and then or operator. So true and false or not of true. That is, you have to take the complement or value of true, which is false. So the next precedence goes as and operator. So true and false gives us a false value or false. False or false is a false value. The result is false. Now we'll execute this. 10 greater than 5 and 7 greater than 12 or not 18 greater than 3, right? So we are getting the result as false. Next example, A, B, C equal to A, B, C and not of 2 equal to 3 or 3 equal to 4, right? So which has the highest precedence? Relational operators has the highest precedence. So here A, B, C equivalent to A, B, C, definitely it is false. And capital A and small a, they are not equal. Not of 2 equal to 2, 3 is false, or 3 equal to 4, again it is false, right? So false and not of. We have to evaluate the brackets. So false or false, again it is a false value. Not of false, which is nothing but false and true, right? So false and true based on your AND operator, that is a false value. Now we'll evaluate the expression. A, B, C equivalent to A, B, C and not of 2 equivalent to 3 or 3 equivalent to 4. The result is false. Next example, length of hello equivalent to 25 by 5 or 20 by 10. And so in this case, the bracket should be evaluated, the function will be evaluated. So what is the length of hello? Number of characters you have to count. So it is 5 equivalent to, what is the next operator that you have to work? It is arithmetic operators, division symbol you have to work, right? So 25 by 2, 5, which is nothing but 5.0 or 2.0, right? So here is a relational operator, 5 equivalent to 5.0, it is true. That is, when the comparison is being done, the floating point value, that is after the decimal place, if it is 0, it is truncated. So it gives the results as true or 2.0, which means that here we have a value, so it is also considered as a true value. True or true will this result as true. Now we'll execute the expression. Length of hello equivalent to 25 by 5 or 20 by 10. So it gives the result as true. Next example, 2 into length of 0, 1. Right. So here in this case, always the inner parenthesis should be evaluated first. So 2 into 2 into, so what is the inner parenthesis? The length of the character string that we have given. So here we have 2 characters. What is its length? It is 2. Right. So what is 2 into 2? Which is nothing but 4. So 2 into 4, that is 8. The result is 8. Let us execute the example. So 2 into open bracket, again 2 into length of 0, 1, right? And one more bracket. So what is the result? It is 8. These are the important questions that is evaluate a given expression will be asked this year. Sample paper also this question has been raised. So please take care children to evaluate these type of questions. Thank you children. To receive our online lesson, please press the subscribe button and you will receive the latest updates.